In the early 20th century, radium was seen as an exciting new radioactive element and was used widely in various products, including paint for watches and clock hands. Girls worked in factories painting these objects, shaping the tips of their brushes with their mouths. They would dip the brush in radium paint, then lick it into a fine point before painting. Over time, the girls began to suffer from strange symptoms: joint pain, swollen jaws, tooth loss, even bone fractures. Some had such fragile jaws that they would break with just a touch. They became known as the radium girls. Despite knowing the dangers, radium companies covered up the truth, falsified medical reports, and blamed the girls, claiming they had other diseases like syphilis, which was common at the time. But the girls refused to stay silent. Although the courts initially sided with the businesses, the girls kept fighting for justice. In the end, after years of struggle, they reached a settlement. The companies paid compensation to the affected women, but the real victory was raising awareness of the dangers of radiation and the importance of worker safety. But how nuclear radiation harms us in the first place?
Follow along carefully so we can understand. Nuclear fission. When the atom splits and unleashes a beast of energy.
A scene worthy of awe and terror.
Scene 1. The atom. A tiny universe. Everything around us, whether solid, liquid, or gas, is made of atoms. Imagine looking at a uranium-235 atom under a powerful microscope. The nucleus, like a tiny ball made up of protons, positively charged plus, and neutrons, neutral, neither plus nor minus, with negatively charged electrons spinning around it. The dangerous secret. This nucleus is unstable and barely holding itself together. Inside it, protons and neutrons are bound by an enormous force, storing immense nuclear potential energy. This energy comes from the strong nuclear force that holds together the positively charged protons, which normally repel each other, and neutral neutrons inside the nucleus. When the nucleus is split or fused, this stored energy is released as heat and radiation, and that's what powers nuclear reactors or nuclear bombs.
So how do we unleash that energy?
The flying neutron is the key.
Neutron bombardment, the beginning of the end.
A flying neutron hits the nucleus, like a bullet hitting a bomb. The nucleus absorbs the neutron, becoming heavier and more unstable. Then, the horror begins. The nucleus splits into two smaller nuclei, plus releases new neutrons, plus an enormous amount of energy. You might ask, why not shoot it with a proton? The answer is simple. A proton is positively charged, and since positive repels positive, it would be repelled before it gets close.
Why uranium-235 specifically?
Because its nucleus is easier to split than most others. When enriched through uranium enrichment, it becomes a potential explosive bomb.
So what is uranium enrichment? And what's the secret behind the number 235?
Ha ha ha! Stay tuned for part 3.